Happy Friday, my friends. Hope you've had a great week. Today, I'm going to talk about data science based on an amazing course that I took here at LinkedIn Learning. And I'll start with a quote from Tiffany Bova, Chief Growth Officer at Salesforce, whom I interviewed on the All Out Coach podcast, who said that data is like the new oil. It needs to be refined in order to be meaningful. Similar to an oil rig that you can drive with your car, pull up to it. Happy Friday, my friends. Hope you've had a great week. Okay, one moment. Data science based on an amazing course that I took here at LinkedIn Learning. Okay, I hear myself here. From Tiffany Bova, Chief Growth Officer. Okay, I'm going to turn off my. Okay, there you go. All right, I was hearing myself there. Okay, so you pull up with your car to an oil rig, and you can't really fuel it up until it gets refined. And that's what data is as well. That Tiffany Bova, I think, used this analogy that makes it very relevant to us, regardless of whether or not we're data scientists. We are all generating data somehow or another. We are all contributing to it. We turn off our phone. We speak about, let's say, a particular product, airplane tickets with an airline, right? And next thing you know, you turn that phone back on and you have an ad that you're pointed towards, that your attention is triggered towards, right? So that Big Brother, that book, 1984, is pretty much a reality today. So today I want to just talk about some of the basics and some of the case studies, and also to describe those categories, those constructs that we often use, and we often do not define or really understand their meaning and how it applies to our life, which I think Barton Poulson, a PhD, who's a researcher and a statistician, he does a great job in this course called Data Science Foundations, the Fundamentals. So I definitely recommend you to take this course. First, let's look at how data science is really structured. Data science contains and requires various different types of expertise. Computer programming, software development skills, which he refers to as hacking skills, for example, as well as mathematics, the statistics, and also domain expertise or substantive expertise in the field in which you are involved. And all of this becomes very important, particularly because of the three V's as well, that are quite easy to remember, and I think we can all understand. Number one, the volume. The volume of data has increased exponentially over the past few decades, and we can attest to this just based on the storage capacity of our flash drives, for example, right, or our hard drives, or even just how our internet speeds have increased and how much data we're able to upload or download. That brings us to the second V, which is the velocity. The velocity of the data has increased exponentially, right? So data is traveling very fast, and that informs our decision making, and which impact many different aspects of our life. And then third, of course, is the variety. You have to be able to sort through this different data, which may be structured, which may be in rows and columns, very neatly organized, or it may be unstructured, such as social media posts that you would want to potentially create a data or trend analysis. And so what I'm often puzzled by is this question, and for the need to record data and then not just store it but refer to it later, but record data that is based off of an entire set of data rather than some subsets here and versus others. And that's why, my mentor's advice a long time ago is one that I still remember. That look, if you want to share ideas with the world, you have to record them first. You have to record them, and so keeping a diary was what my mentor recommended, right? An ongoing diary. So it's very difficult and challenging these days to keep a diary, right? And so we have to employ a lot of different technologies and different skills. Now, the data science can be defined as the skills and techniques needed to analyze and process challenging and complex data, because the data we now can probably appreciate has become more complex than ever. And we know that also a lot of the misinformation may travel faster, in fact, 6 times faster than valid information or accurate data, right? And so it becomes very important and often life-saving for many people to be able to analyze the right data, and not just bring our attention using various triggers that AI may find, but all the context of our of that data, right? If it's negative data, if it's misleading data, then our attention that AI may trigger us towards may lead to the wrong decision. Okay, so getting back to the data science and how it relates to AI and ML, machine learning, there is an overlap. There's a huge overlap, and this is why categories, as he mentions also, and as I concur with him, absolutely, are constructs. There are mere constructs that we use in our language. The borders between, however, may be much less defined. They may not be well defined. And so this is the Venn diagram that he uses in this course at LinkedIn Learning, in which machine learning and AI overlap, right? And NN here stands for neural networks. So AI it refers to the ability of a computer or a machine to learn from data, all right? To learn from data. And machine learning as the algorithms needed to predict various trends or patterns. Now, one thing that machine learning and artificial intelligence help us with is the memorization, right? The memory and just the storage of data, of course, right? Because our memory is limited, our human memory. Now, our ability to identify patterns may be much more instinctive and better, let's say, than the computers. However, the computers can be trained. Our machines, our software can be trained to improve their pattern recognition at scale and improve patterns of recognizing not just small sets of data, but much larger sets of data. So in healthcare, for example, that's important because we are able to now redefine what evidence-based medicine is. Because evidence-based medicine refers to our ability to base our decisions in healthcare based on valid, randomized, controlled data, most relevant data. But because that data has now expanded, AI, machine learning, data science are now redefining what evidence-based medicine really is. Now, a few comments on the neural network here, right? So the NN here, neural networks, and I'll talk about this a little bit later in more detail. These are the types of software programs that are built that replicate our neurons in our brains as well, in our brain. Okay, so they consume a lot of individual small bits of data, maybe pixels of this video or the photo or the image that you may be seeing here. Uh, and it's analyzing and processing and combining all of those individual terabytes of data often in order to create a particular prediction. Okay, or develop or identify a particular image, for example. But we'll go into that a little bit in a little bit more detail later. Now, the data science pathway. There's a sequence to how data science can become impactful. All right, and that sequence really first requires planning. All right, planning of the data. So you have to plan the data, meaning you have to organize what those resources that you're going to use are. You're going to have to define the goal. What is the goal of your project, your software program? Is the goal to discover a new drug? Is it to predict a particular probability of the test of your of a test you use to identify the presence of a disease, or the likelihood of a particular new member of your insurance company to be involved in an accident, for example, right? And so there's limitless use cases here, but it's important to first define the goal, then to start wrangling the data. Now, what does wrangling refer to? Wrangling refers to, in data science speak, to preparing the data, because those of us who are not in data science often do not appreciate how difficult and how time consuming it is to scrape the data, to clean it in order to make sure that the data that we ultimately use, the input that we use, is actually valid and relevant for us to then start analyzing it and refining it. Okay. Now, the third step is, of course, to model the data. And you can model using math, using statistics, and also using more high-tech tools such as software programs, AI, machine learning to learn the data. Now, one important aspect of modeling of the data is that we often make lots of errors, in our models, right? But it turns out that the more data that you use, and once you combine these models together, you are able to these models, they cancel the errors cancel out. Okay, and so it's sort of like shooting a bullseye, right? And making many attempts with your arrow, but once you then combine all of your attempts, your average attempt becomes closer to that bullseye, right? More accurate. And so that's the central limit theorem that he describes, and that he reminds us of. And that's why the more frequently, the more regularly you collect data that is relevant, first and foremost, the more accurate it becomes. Okay. And now, so then once you model that data, and once you use all the different models to separate the signals from the noise, because that's also what ensemble models allow you to do, then you apply that data, right? You apply it, you deploy the data, and you refine those models, because the question that you may have been asking may no longer be relevant. The goal, you may change your goals that you need to in order to grow, or to be competitive and to stay relevant. Okay. Now, who are some of the people that make up a data science team? Once you have the sequence down, once you have your goals in place, it all starts with the engineers, okay, with data engineers. These are the experts who have the know-how of the technology, the foundation of that is needed for any algorithms to run on. So they use the right language, the right program, and they know they can build the architecture that's needed in order for that for that program to become a museum, that people buy tickets for in order to enter that building, if you will, right? So then you have machine learning specialists. These are those types of scientists and experts, data science experts, who have the experience with creating the right algorithms, the right neural networks, using that language, using that architecture that engineers provide. And then you need, of course, domain-specific, field-specific researchers or experts who are able to make that relevant, to make those the artificial intelligence programs, the machine learning algorithms relevant and valid, and also predictable for their field. Okay. And then afterwards, you need analysts to be able to visualize that data, so that other people who are less familiar with that field may use it in a commercial function, for example, right? And so visualization of the data becomes extremely important, right? And it uses different programs as well. Okay. You have managers who are part of the data science startups and data science organizations who have no intimate or direct knowledge of data science principles or programming language. But what they're good at is making sure that all the projects meet their milestones, that they're orchestrated well, and they're aligned to the goals. All right, so that's a very important function. Now, there are also full stack data scientists who are very rare and hard to find, apparently. Okay, and so these are the kinds of experts who usually don't stay in one organization for very long, and they are also very expensive. But they're able to actually integrate all of these skills that the engineers, the machine learning specialists, that the researchers and managers have, and so they're kind of the most valuable players, if you will, right? And experts. Now, what languages are used? But what are the programming languages that probably we should be familiar with? Well, Python and R, that are used by statisticians, but to even more extensively by data science experts. These are the programming languages for manipulating the data, for modeling the data. Then you have the C, the general purpose languages, the programming languages that we may have heard of, that necessarily do not translate into an AI program or a machine learning. However, they are important to code, right? To use code, right? Programming code. The analysts and other experts, they use SQL in order to interpret the data, to visualize the data as well, and to connect the data to a particular function. And there's also a database, which is an open source database used for deep learning, for neural networks, and that it's called TensorFlow, which is very important because the databases, the size of the database, and the training data sets, as data science experts often refer to, are critical in our ability to replicate, to scale our accuracy, and also the speed with which we can determine an output or a particular decision that may be the recommendation as a result of that program. So in the healthcare industry, in the pharmaceutical industry, to be more specific, there are a number of private databases that determine a drug target interaction activity or molecules, many of which 90% or 99% of which never make it into the clinical setting, and that are never tested in humans even. Okay. Nevertheless, a lot of these medications can be repurposed for new indications, for different disease states. And we have plenty of examples like that in healthcare, in the pharmaceutical industry. And not only, right, in the culinary world, right, the most traditional recipes today are actually born from mistakes from yesterday, from decades ago, from our grandparents. Okay. And so it's important to also revisit the past with the eyes of a 5-year-old, for example, or with a fresh perspective, in order to make meaning out of that data. But again, it goes back to the data sets, and so the training data sets are lacking currently. Yes, we have high throughput testing that we use in drug discovery. We have various different other technologies, but nevertheless, what various different neural networks and deep learning databases help us with is to augment those databases. And I'll explain a little bit why that may be important in drug discovery. Looking at our the programs that we use, now let's shift gears towards the deep learning and neural networks and how they are structured. First, as I mentioned, this relates to a computer program or a software development company that is able to process a lot of small individual bits of data, pixels, for example, or it may be a use case in human pathology. And I recently learned that there is up to a 12% error rate among human pathologists who may not have the resources necessary, or just as a product of their own human limitations, they may not be able to identify or distinguish a cancer cell versus a healthy cell, for example, despite their expertise in human pathophysiology. And so machine learning and AI can help build that business case, which Bayer in their LinkedIn Live recently featured. By employing this technology, it can augment, not replace, but augment the human's ability to distinguish different cells under a microscope, for example, right? And so in order to do that, terabytes of data, not gigabytes, but terabytes of data are needed for every single different configuration of that cell. And it may be configured many different ways, in real time. It's dynamic, right? And so how a healthy cell interacts with a cancer cell undergoes many different changes, okay? And these require recording in that diary that I mentioned earlier, right, by my mentor. But AI and medical and machine learning have the capacity to manage and to process all of those terabytes of data, okay? Now, and so getting back to the neural networks here, so what happens is in facial recognition, for example, or when you visit a website, okay, you're asked to be distinguished from a robot, right, by being able to identify various different images, okay, correctly, right? How many of these images are a boat, right? And if you're able to click the right ones, you go on to the site, or you can log in, right? Well, the computer itself is that same technology is analyzes all of that data, right, by pixels, by the XY axis, right? That XY axis that you have here, and the colors, for example, the red, the green, the blue. Okay, and it uses this input to replicate our neurons, our own neurons, because they make different connections. So these connections that you see here, right, they're similar to when we sense pain. Okay, when we have that pain impulse after we hit an object, right? We hit this wall here, right? And our hand starts to hurt, right? That's a sensory input here in the periphery, but it's that those neurons travel to our brain, right? To our spinal cord, to our brain, and back, but through these hidden networks, right? That you may not see, but these are the hidden layers that make up these neural networks, these software neural networks. And these hidden layers, they are able to, in the case of an image, for example, make these connections and determine that a particular color against a contrast connected to another one may be aligned. All right. And those lines it then uses in another layer of neurons, if you will, hidden layer, to demonstrate that they are an edge of something else, okay, based on the input. And this requires, again, a lot of individual, intricate level of detail, okay, and data. So once the program is able to identify some edges, they use other neurons, a set of other neurons and their connections with other hidden layers, in order to then demonstrate whether or not they're shapes or not. Okay, and the output lets the user know whether or not something is a circle versus a square, whether it's a bear, it's a boat, it's an animal, or recognize your face, right? When you in facial recognition, which is very important in security, for example, right? In in privacy issues. So that's in essence what a neural networking and what deep learning refers to, which again, I'll remind you in that Venn diagram may be a part of both data science, AI, machine learning, and AI as well. So there is a lot of overlap. Okay. Now, I promised, in the post to talk a little bit about the ethics as well, right? Since I've already alluded to it, that the information may be difficult to explain or interpret, right? The information that AI or machine learning may lead us to. In Europe, there's a very strict law that's called the GDPR, the General Data Protection Regulation, because and it's important in order to balance all of those benefits and advantages that AI and data science can provide us with the risks. Okay, and so the risks may involve someone who's directly impacted by your technology, your innovative technology that you have developed. For example, if they're getting a loan, right, and that decision that you make that's based on AI or on ML may either render them eligible or ineligible for that loan, or they may qualify for a higher premium or a lower premium for a car insurance based on how you analyze that data. So apparently now the consumers of data, of technology, have the right to ask for an explanation. Okay, the right to explanation, which may become quite a challenge if you build a program that has a very complex set of neural networks in the deep learning model. And so, because a lot of this regulation may carry quite significant and high fines, it's quite important and critical, I would say, to implement a accountability program, an AI accountability program in your company. Recently, I took a survey from MIT Sloan Business School of Management, which generated data, which surveyed many different new AI companies in order to learn whether or not they had indeed developed their own AI responsibility or AI accountability program, and how it was structured, how the training took place. So, from this live, one of the big takeaways that I want you to consider, if you are a data scientist, if you are building a new company, is to implement and institute an AI accountability program, because our technology has wide, far-reaching implications to our society and many aspects of our world, in healthcare and beyond, that can impact the sustainability of our life as well. All right. What are some other applications of this? Well, I mentioned somewhat, I talked about the cars, right? And so, self-driving technology, we use machine learning. We may not really be very well versed in data science or machine learning or AI, but we're all, again, either contributing to it or we're utilizing it. Cars that we sit in, they have lane shifters, lane shift technology, which interprets the traction of your tires, the weather conditions, or the physical vicinity, the immediate vicinity of your car at any given millisecond, and it interprets those signals through these neural networks in order to then either direct the car to turn the steering wheel left or right, okay, and to uh, help you stay in your lane when you fall asleep, for example. Now, are all the manufacturers at have all of them reached 100% accuracy? No, they haven't. But at certain speeds, or there are certain thresholds after which some manufacturers have made this very useful and relevant. Now, again, I'll go back to that aggregation of different models, example for that. I again was reminded by Dr. Barton Poulson in this LinkedIn Learning course, that the more data, the greater the training data sets that you have, the more accurate your decisions will be. Okay, so there's a lot more we can learn and we can look forward to in this technology as well. So, not always do you really need to employ AI and machine learning. Okay, and Excel, various different models, mathematical models, may come into play as well, and they may be quite as valuable, and if not just as valuable, at times. All right. So when you have data that can be described by lines and by rows and columns, you can use linear regression, various different lasso regression, various different models. And I want to highlight one particular case study in order to also demonstrate how something can be some concept, some mathematical or statistical concept can be predictive and can determine and improve your decision in the future. But before that, I think we need to make a distinction between what are predictive analytics and what are prescriptive analytics. Okay, and here Dr. Barton Poulson makes an important point to say that predictive analytics refer to that data that the variables for which are correlated. All right. So think of. I want you to think of predictive analytics as correlation data. All right. Okay, so I'm going to put this up here. Oh, whoops. There we go. So correlation data. So what is correlation data? Well, correlation data is merely the observation that within the presence of one variable, there is this second variable that is all that it may be also associated with. Okay. Now, once you determine that the inputs that you have are the definitions that you use are valid, they are descriptive, and that you've determined that now they may be correlated with this other variable that you want to test, and they're predictive based on this large data set, then you want to demonstrate that something is prescriptive. Okay. The analytics and the data science helps you prescribe a particular decision, diagnosis, right? So how is a prescriptive how are prescriptive analytics different? Well, they indicate prescriptive analytics indicate causation. All right. I'm trying to write this down here for you just to have it on the screen as well for the visual effect here. All right. All right. So prescriptive analytics determines the causality. All right. So how does he really define causality? Well, the causality is determined by the fact. So the causality definition, according to him, is number one, that there is an observed correlation. All right, there is an observed correlation between one variable and the other one that it may impact. Number two, that there is a temporal relationship. Right, there's a temporal precedence of one before the other. Okay, that means that if you have another variable that occurs after the one you're trying to test, it couldn't be causing it, right? That's retrospective analysis. Okay. And then third, that there's no other explanation possible, period. Okay. Which is kind of, it eliminates any other explanation. So that's a very mathematical kind of a definition, but a very operational one in my mind. All right. Now, business intelligence is something that we probably need to talk about as well here, because business intelligence is a field that is also a subset of data science, of analytics, and it employs all of this data, the predictive and the prescriptive analytics, in order to apply it, right? In that last sequence of that pathway, the data pathway I talked about. So business intelligence ultimately applies various different models and to make interpretations for various different functions, for the commercial function to be able to visualize, right, and to interpret, to make it relevant without the requirement of the knowledge and the know-how for data science. All right. So having these concepts and kind of, categorizing, classifying them in some way now and simplifying them, if you will. Now, I want to share a case of a mathematical concept that doesn't require calculus and algebra, which actually is very useful and relevant to solve many problems in data science. However, this theorem can be used to explain how accurate and how the expectations to have from a particular test in order to identify the presence of a disease, for example. So the Bayes theorem says that a posterior event, or the probability of a posterior event, equals the likelihood of that hypothesis times its prior occurrence over the marginal probability, or that the data that you found, the overall data that you found, is correct. Okay, so how do we apply it? How does Dr. Barton Poulson apply this? Well, let's look at consistent definitions in terms of the base rate of this one particular disease, which may be thought to occur 5% of the time. So this particular disease occurs in 5% of patients, people tested. The true positive, among those who test positive, 90% end up having the disease. Whereas those who do not have the disease, 10% of them could be positive, could test positive as well. So 10% false positive rate, 90% true positive rate, and a 5% overall disease prevalence. All right, those are the numbers that I want you to remember. Now, this is important, particularly during the COVID times as well, when all of us are testing. We are all testing, and we're testing at different times when the symptoms occur, before the symptoms occur. And so it's in a very real world application. All right. And now the question that Dr. Barton Poulson poses is, if a person tests positive, then what's the probability that they have the disease? Your natural instinct, and so is mine, is to say that, well, 90%. Because if we already said that among those who have the disease, 90% test positive, then maybe the contra positive of that logically may be also true. Well, this Bayes theorem proves otherwise. That a person who tests positive they may not be expected to have 90% likelihood of having the disease, because if you look at this subset, and this is just a screenshot from the LinkedIn Learning course, 90% of those patients who test positive, of 90% of those patients in the whole population that have the disease, which is 5%, equals 4.5% of total true positives in the population. Now, among those who do not test positive without the disease, among those patients who do not have the disease, and we know that that's 10%, 10% of the 95%. So 95% do not have the disease. Well, because the false positive rate is 10%, 10% of 95% is 9.5%. So there's a 9.5% rate of false positives, okay, among those patients who do not have the disease. And now, the posterior then probability of disease, when you apply the Bayes theorem, is that true positives are divided by the true positives plus false positives to understand what is the overall likelihood that we can expect that positive to be true in the population overall. So that's 4.5% divided by 4.5 plus 9.5%. And that turns out to be less than 1/3. So less than 1/3 of the patients who test positively in this case, in this arbitrary case, which is not, actual, may demonstrate to have a probability of disease. So that test may not be that accurate, right? Applying this mathematical concept, okay? And so with now, if we talk about how we can utilize data science in different ways, right? There we can also measure productivity, right? And I've spoken about this many times before. I'm building a medical productivity index in order to predict future performance and behavior, where I'm quantifying not only performance but behaviors as well, simply because of my interest, probably lifelong interest of math and exact sciences, and being able to interpret them and apply them to behaviors and abstract concepts, right? And so I've merged them both in my concept. And I want to now share with you a video of how Dr. Barton Poulson has done something similar, where I'll remind you that in my medical productivity index, I list all the activities that we want to measure in a particular function, in a particular role, and then you rank them according to their relevant impact on an outcome, right? Whether it be financial outcome or others. And I also then follow that over time, report that prospectively in the performance part of the equation. And so in order to come up with a particular prediction for what type of activities to then engage in more in the future, right? What kind of behaviors to reward and how. Not only the performance, but also to measure, again, behaviors by those people who are directly impacted by those activities and behaviors in multiple directions, not in one direction, but bidirectionally. Those not only in one function, but also cross-functionally. So you're getting a more 360 kind of input on the activities and behaviors in that MPI. But looking at just performance alone, okay, looking at just the activities, take a look at how you can use an Excel function, an add-in, which is called Solver, as Dr. Barton Poulson explains, in order to optimize particular activities, rate them, rank them, and then choose to emphasize one particular activity versus another as you build a business.
Time trying the ins and outs of how this works. I'm going to be using a little piece of software that is an included add-in called Solver for Excel. And what I've done is I've set up a hypothetical situation where a person owns a yoga studio and they're trying to maximize their revenue for the amount of time they spend. And the first thing I do is over here I put down a list of possible things a person could spend their time on, from responding to social media and writing a newsletter, to teaching classes, to recording videos. And I say about how long it takes to do each one and how much each of those impacts the bottom line. And then one of the important things about optimization is putting in constraints. And so here I say we need to do at least this many on the left, we need to do no more than this many on the right. You know, you have to respond to your email, but you can't teach classes all day long. You get burned out. And so you have these minima and these maxima. And then we're going to use the solver to try to find an optimal number of units, how much of your time you should spend on each of these activities. We're going to maximize the impact, which is basically revenue. And then we're going to make it so it's no more than 40 hours because you still have a life you got to live. Now, when you call up the solver dialog box, it looks like this. This is where you say what you're trying to maximize, what you're going to constrain, what it's allowed to change. And there's a number of options here that can get pretty complex. Again, my goal here is not to show you how to use it, but simply that it exists and it can solve this kind of problem. When I hit solve, what it does is it adjusts the column in F. And it says, this is your optimal distribution. It says spend this much time on each of these things. And what that's going to do is going to maximize the impact, which is going to be associated with revenue. And it also says how much time you're going to spend on each one. I also put a little dot plot here on the end just to give a visualization. You're going to spend most of your time teaching group classes in the studio, but you'll do at least a little bit of everything else as a way of maximizing the impact. This is a way of reaching a conclusion about the optimal way of allocating your time, maybe even recruiting a team without having to go through billions and billions of possibilities. That's one of the beauties of data analysis and data science, to help you cut through the mess and find the most direct way to the goals that are important to you.
Okay, well, I think that's a great way to end this session here, this live session. I hope you found it useful. I wanted to really finish with Dr. Barton Poulson, who's a PhD again, an expert in this field, of this live. And as you saw here, I talked a little bit about, again, the data science as a field, how it relates to AI, medical, and machine learning. We talked a little bit about the different paths, that various different companies can use. That data science pathway, the roles, the teams on data science companies or data science functions, the individual roles, how they relate to one another. We talked about the trust issues, of accountability, responsible AI, as well as the different subsets of data science, the predictive versus prescriptive analytics, business intelligence. And also we applied low tech and also described neural network and deep learning and how it applies in various fields, medical, healthcare as well. So the next session on this topic, I'll use another course on AI accountability to share with you some updates from what I learned there. So I hope you found this useful. Look forward to your comments. Analysis mediates your edge in action. Remember that. I hope that you find this information again relevant, and I look forward to hearing from you. Thanks, guys.